Did you know that the color blue is very rare in nature? Sure, the sky and the ocean are blue, but take a moment to think about the last time that you saw a naturally blue flower. There isn't even a blue fruit that exists. Blueberries aren't even blue. They're purple. And I can't even remember the last time I saw a blue butterfly or bird that wasn't in a zoo. It's that rare. This brings up the question, how and where do people obtain blue pigment, dye, or ink for pictures and shirts and stuff? Well, the answer, my friend, is chemistry. Sounds interesting enough, right? Keep watching to know more about it. As I said before, there are rarely any true blue pigments found in nature, so people must get them from somewhere or something else, right? Well, you're in luck, because with the help of another chemistry kit from HALscience, I'm going to show you just how these blue pigments are made using chemistry. But before we do, let's put on our safety gear. I've already put on my lab gown, so now I'm going to put on my gloves. After that, I'll put on my mask, and then finally, my safety goggles. Now, I'm going to list down the things we'll be using for the experiment so that we all have a basic understanding of what they are. First off, we have a plexiglass plate. Then, we have citric acid, ferric ammonium sulfate, ammonium carbonate, and potassium ferricyanide. We also have a table lamp, which we're gonna use as a source of energy in the form of light. And lastly, we have a negative image that we'll be using as a design, and some paper as well. Now that we got that covered, let's proceed with the experiment. First, I'm going to make a photosensitive mixture by mixing 1 big spoon of citric acid, 1 big spoon of ferric ammonium sulfate, and 1 big spoon of ammonium carbonate. Next, I'm going to add in some potassium ferricyanide. I'm then going to gently swirl the mixture around until the components are thoroughly mixed. Once we have our photosensitive mixture ready, I'm going to apply it to the watercolor paper using some cotton. Once it's spread around the paper evenly, I'm going to lay the negative image on top of it. Then, I'm going to use the plexiglass as a weight so that the layers underneath it are secure. Once I'm sure that the paper and negative image aren't going anywhere, I'm going to shine a light on it. The light should be around 10 centimeters away from the glass. Then, I'm going to wait for 10 minutes for our image to develop. Alternatively, you can also forego the lamp and instead expose the image to sunlight for about 3 minutes. You should still be able to obtain the same results regardless of the method you use. Once the 10 minutes have passed, I'm going to wash the paper with water to remove the excess photosensitive mixture. You should be left with a nice blue and white image. Some manufacturers of clothing use the same method to print blue designs on shirts. Although it's not the only method to obtain blue pigment, the cyanotype process surely is an interesting way to do it. I'm not one to keep people waiting, so let's get to the explanation part of it all. Basically, the light coming from our table light serves as a form of energy, and many substances absorb it readily. When light hits a ferric ion from the ferric ammonium citrate, it initiates a reaction where the ion gains an electron, reducing into a ferrous ion. The product of this reaction is not yet visible, but when potassium ferricyanide meets the ferrous ion, it forms an insoluble and intensely colored compound called Prussian blue, which is what we see in the image that we made. If you wish to see more things like these, hit the subscribe button and make sure you turn on all notifications so that you never miss an upload. Also, give this video a like if you enjoyed and share it with your friends who you think might be interested in the wonders of chemistry as well. Thanks for watching! Bye!